1 part 2 asks you where a line intersects two distinct points. So when you see intersect, it means you have to sub two different equations into one, as in this case it's these two equations, and the substitution must be in a way such that it only leaves you x values and it gets rid of the y value altogether. K is alright since question asks you for all values of k. Now before we go on, let's look at two distinct points. Back to refresher, when discriminant is more than 0, discriminant being this, right, the curve and line can intersect at two different points. Again, this has many different representations. It can be like a straight curve and a horizontal line, but in essence it just means two different lines. It can be a curve and straight line, curve and curved line, not straight line and straight line, because it doesn't make sense. If it's equal to 0, it means intersect only one point only. Less than 0 means not touching at all, no distinct points. This part most of you should know. So let's go back to subbing. You sub all this value into y, so this whole thing is y. Plus 2x here is 1 plus 2x here, and 12 in here, 12 in here. Now let's simplify and make sure kx is all grouped into these brackets here. These two brackets here. So that is very clear, as seen over here. Lastly, discriminant b square minus 4 ac being more than 0. Just a mild modification, because I realize this question is not really easy at all. Simplify and simplify. But something's very strange here. You realize that actually, if you use this and type in your calculator, you get no real roots. Yet questions still ask you for all values of that it fulfills this criteria. So what can actually be done here instead is we avoid this method altogether, and using purely this, get our analysis. Just briefly copying over. So how do we conclude that this is always more than 0? We look at this square first, which is the main biggest hint. What you can do is that since square of anything will always give us a number that's more than or equal to 0. Let's say for this case when k is 2, that's the only case where you get where this thing is equal to 0. If k is, let's say, a positive number, let's say example, k is equals to minus 2. Sorry, not minus 2, 3. You realize that 2 minus k square is equals to 2 minus 3 square, which is minus 1 square, which actually give us just the same. If k is minus 3, you get 2 minus minus 3, which is 2 plus 3, you get 5 and 25. You always be a positive number otherwise. Only case is when k equals. Thus, this chunk will always be more than 0, referring to this layer actually. To play safe, you can write discriminant over here, and even all values of k. But otherwise, this is your answer for 1 part 2.